Instrument cable, routing, tubing, a tutorial. Electric cabling, design basis and functional layout. Electric cabling for instrumentation must ensure precise and resilient signal transmission in all operating environments. Signal integrity depends on solid insulated conductors, minimum diameters 1.13 millimeters for singles, 0.8 millimeters for multi-cores, and accurate voltage drop calculations. Signal wiring from field devices to junction boxes uses single cables, while multi-core cabling conveys signals to central or auxiliary control rooms. Underground routing is preferred for multi-core runs due to its superior protection against fire and mechanical damage. Above-ground runs are acceptable if justified economically and approved by the principal. Cabling exposed to potential physical or chemical hazards must incorporate steel wire braiding, SWB, or steel wire armoring, SWA. Additional chemical or moisture barriers are necessary if HDPE sheathing is not included. Signal segregation in multi-core cables. To minimize EMI and ensure signal fidelity, multi-core cables must comply with strict segregation rules. Intrinsically safe and non-intrinsically safe signals must be routed separately per IEC 6079-14. Signal class compatibility must be observed. Thermocouples, for instance, require homogeneous cabling based on type. Signal pairs must include both supply and return conductors. Segregation by discipline, e.g. electrical versus instrumentation, is recommended. Functional segregation by system or area enhances maintainability and diagnostic clarity. All multi-core cable installations must retain a minimum of 10 to 15% spare capacity to accommodate future plant modifications. Cable selection and construction principles. Instrumentation cabling shall use copper conductors unless otherwise specified. For thermocouples, extension wires must match the thermoelectric properties defined in IEC 600584-3. Resistance thermometer cabling must comply with OEM resistance requirements. Signal pairs shall be twisted. Quads require principal approval. Cables must feature collective screening with a drain wire for signal levels 1 to 3. Underground cables should prioritize AL-HDPE-PA sheathing to resist moisture and chemicals. Cable types must align with environmental placement. Indoor, PEMS PVC screened PVC sheathed. Above ground, PEMS PESWB PVC. Underground, PHP PASWHDPE. For signal levels 4 to 5, cables must have at least 2.5 mm conductor cross-section and comply with low-voltage cable standards. Signal Class 6 fiber optic cables must meet requirements from DEP 32.71.0 per DAT. Gen. Digital and video cabling. Systems requiring digital or video signal transmission, such as microprocessor-based instrumentation or CCTV, should use appropriate media based on bandwidth and distance. Twisted pair, coaxial, or fiber optic. Fiber optics are preferred for high EMI environments, lightning exposure zones, and long-distance communication between central and auxiliary rooms. Special application cabling. Non-standard instrumentation, e.g. flow meters, analyzers, machine diagnostics, often demand unique cabling and termination practices. Manufacturer guidelines shall govern selection, shielding, routing, and earthing. In select cases, bypassing junction boxes and MDFs in favor of point-to-point runs may be necessary. Fire-resistant cabling requirements. Critical system cabling, such as for remote-operated valves, ROVs, fire protection, and depressuring services, must maintain circuit integrity during fire scenarios. This may require fire-resistant construction or protective coverings. Fire-resistant cable must also withstand chemical exposure if applicable. System cabling for efficiency and accuracy. To reduce on-site labor and connection errors, prefabricated system cabling shall be used wherever possible, especially in control and auxiliary rooms. Use of standardized cabling systems provided by DCS and IPS vendors is strongly recommended. All third-party system cables must include OEM-approved connectors and pass certified testing protocols. Cable construction and application compatibility. Cables used for signal transmission in instrumentation must be constructed to meet electromagnetic compatibility, EMC, mechanical durability, thermal tolerance, and environmental protection requirements. For signal level classes 1, 2, and 3, typically low-voltage analog and digital signals, cables must be screened with a metal shield and include a drain wire to control interference. Collective screening is standard. Individual pair screening is applied only when functionally necessary, such as in high-precision measurement loops or noise-prone areas. Cable construction must not invalidate the requirements of intrinsically safe or non-incendive circuits. Capacitance, inductance, and resistance must remain within limits that preserve safety barriers and system signal integrity. Underground cables should utilize AL-HDPE PA sheathing for combined moisture and chemical resistance. For harsh conditions, cable armor should be steel wire armoring, SWA, for underground runs, or steel wire braiding, SWB, for above-ground installations. Typical cable constructions based on application: indoor controlled environment, polyethylene insulated conductors with metal screen and PVC outer sheath, PE/MSH PVC, used within control rooms or auxiliary buildings. Above ground industrial environment, polyethylene insulated collectively screened cables with additional PE bedding, SWB mechanical protection, and PVC outer sheath, PEMS PESB PVC, suited for tray or trunking installation in the field. Underground harsh environment, polyethylene insulated cables with AL-HDPE PA barrier, SWA for mechanical protection, and HDPE outer sheath, PEAL-HP HDPE, provides resistance to chemicals, moisture, and mechanical loads in buried applications. Special considerations for thermocouples and resistance elements. Thermocouple extension cables must use the correct dissimilar conductor materials to maintain the thermoelectric characteristics specified in IEC 60584-3. Mixing types within a multi-core cable is not allowed. Resistance thermometer cabling must be selected to ensure that lead resistance does not distort temperature readings, often requiring matched low-resistance copper conductors. Cable conductor requirements. Solid conductors. Recommended for field cables due to mechanical stability and termination clarity. Minimum diameters 1.32 millimeters for single core, 0.8 millimeters for multi-core. Stranded conductors. Permissible for internal cabinet wiring only. Require crimped wire pins/lugs for screw-type terminals to ensure gas-tight, corrosion-free contact. Solid conductors must not be used with crimp-on pins. Current and voltage considerations. For 0.8 millimeter diameter conductors, approx 0.5 millimeter squares, the continuous current rating is 1 A per core with a fuse limit of 4 ACE. Voltage drop must be calculated for each loop to verify that instrument terminals receive sufficient supply. Where the drop exceeds permissible values, larger conductor diameters or adjusted power supplies must be selected. Cable types for higher signal levels, classes 4 and 5. These cables carry higher energy signals, e.g. solenoids 110 volt DC systems, and must be constructed accordingly. Conductor cross-section, minimum 2.5 millimeter square. Cable insulation and sheathing, flame retardant, mechanically robust, and EMC compatible materials. Screening, applied as required based on proximity to instrumentation or other low voltage cables. Fiber optic cabling for Class 6 signals. Used in communication buses and long-distance signal paths, fiber optic cables offer immunity to EMI, intrinsic safety, and bandwidth capacity. Selection must consider environmental toughness, minimum bend radius, tensile strength, and compatibility with termination hardware. Optical loss and mechanical performance must be validated during installation testing. Cabling for digital and video signal transmission. Instrumentation systems incorporating microprocessor-based control, digital communications, or video surveillance require cabling optimized for data integrity, bandwidth, and noise immunity. Digital signal cabling may use screen twisted pairs, coaxial cables, or fiber optic lines depending on application demands. For short to medium distance communication within protected areas, screen twisted pair or coaxial cables may suffice, provided shielding is effective and terminations are properly grounded. For long distance runs, exposure to EMI, or lightning-prone environments, fiber optic cabling is preferred due to its immunity to electrical interference, non-conductive nature, and high data throughput. Digital instrumentation, including remote I/O systems, analyzers, and data acquisition networks, must be matched with appropriate cable types that support required bit rates, propagation delay limits, and voltage levels. CCTV and video feeds, particularly analog systems, should use coaxial cables with 75 ohm impedance, while digital video over IP may transition to Cat6, KT7, or fiber optic lines. Cabling for special instrument applications, devices operating outside the conventional 4 to 20 mA signal standard, such as ultrasonic meters, magnetic flow transmitters, vibration probes, or multiplexed analyzer systems, require special consideration for cabling and earthing. These applications may include unusual voltage or frequency characteristics, which dictate custom shielded, impedance matched, or low loss cable designs. Cables for such devices often must avoid intermediate terminations like junction boxes or MDFs. A continuous run from transmitter to receiver is recommended to preserve signal quality and reduce insertion loss. Manufacturer guidelines must always be followed regarding cable type, length restrictions, grounding, shielding, and installation routing. Fire damage protection for critical cables, above ground signal cables that serve emergency shutdown systems, fire protection interfaces, depressurization circuits, or remotely operated valves, ROVs, must maintain operational integrity during fire exposure. This is typically achieved through either fire-resistant cable construction or by routing cables through fireproof conduits or enclosures. When selecting cables for fire-critical duties, key performance criteria include flame retardancy, smoke emission class, resistance to chemical attack during thermal events, and survivability duration under flame, e.g. 30 or 60 minutes at 750 degrees Celsius or higher. Installation routing should prioritize low fire risk zones, and where crossings with potential fire sources are unavoidable, additional passive protection such as intumescent wraps or mineral sheaths may be required. Fiber optic cabling requirements for signal level class 6. Fiber optic cables used in high-speed communication and signal class 6 applications must comply with optical, mechanical, and environmental specifications to ensure long-term performance. Core selection, single mode or multi-mode, jacket material, UV and chemical resistant, armoring if used, and fire behavior must all be suitable for the installation environment. Proper termination is essential to minimize reflection loss and signal attenuation. All installations must respect manufacturer-specified bend radius, tensile loading limits, and connector compatibility. Connectors should be dust protected and physically secured against vibration and accidental disconnection. Optical loss budgets should be calculated and verified by testing using OTDR or insertion loss measurements. System cabling for modular signal management. To streamline instrument loop installation, system cabling should be employed wherever signal density, complexity, or error risk is high. In particular, modular distributed control systems, DCS, and instrumented protective systems, IPS, often support prefabricated system cable solutions for I/O card termination. These cables, manufactured with OEM-specific connectors, reduce human error and commissioning time. In auxiliary rooms and control panels, system cables should be logically routed to pre-designated boards or termination blocks. Connectors must be rated for vibration tolerance, contact resistance, and pin alignment integrity. Test certification and vendor compliance are mandatory. Spares must be incorporated at a rate of at least 10 to 20% to allow for system expansion or field modifications without retrofitting core cabling infrastructure.